Yeah. Great warm-up. Love this warm-up. Excited to be part of this warm-up. Yay. For warm-up. Good so far? So I get my first term is -8. My common difference is 3. So my the stepsister rule or stepdaughter rule, whichever one the Disney princess type things are in, is this one. And the princess rule is 3n minus 11. Yes? Good times. So today we're going to talk about sums. We're going to find sums of series. So we're switching from sequences now to series. Okay. Yesterday I gave you this one. A tall brick building has a decoration as shown. Each brick has a height of 1 foot. How many bricks would it take to build the decoration of 15 feet? Oh, okay, we're getting closer and closer and closer. We could figure out now that the first row has 1 brick in it. And then there were 2, and then there were 3, and then there were 4, and so on and so forth, which makes our common difference be 1. So my rule here would be 1 plus 1 times n minus 1, or just n, that's a bad n. Or just n. Oops. So we could answer the question that there would be, how many bricks would it take to build a decoration? Well, we're getting close to that one. But yesterday, the other question was, how many bricks are in the 15th row? According to our rule, there's 15 bricks in the 15th row. Okay. So today now, we need to find how many bricks are in the 15th row. We just said there were 15. Okay? And so we would find the number of bricks by adding up all the different rows. Well, that would be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. There's lots of bricks. Okay? And then manually, we would have to add those up. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, plus 6 is 21, plus 7 is 28, plus 8 is 36, plus 9 is 45, plus 10 is 55, plus 11 is 66, plus 12 is 78, plus 13 is 91, plus 14 is 105, plus 15 is 120. So there are 120 bricks in our design. A lot of math. Okay? And there's got to be an easier way. And with arithmetic sequences, there is. Okay? And that easier way is the summation formula. Okay? So the sum of the first n terms, or the sum of the n total terms in a series, is the total number of terms n divided by 2 times the quantity, the first term plus the last term. We need to have those 3 in order to get that 1. You got to have those 3 in order to get that 1. Right, got it? Okay, let's put it to work. Okay. So, there is our arithmetic series. So, we first need to find our first term. What is our first term? 3. We need to find our last term. What is our last term? 48. We need to find the total number of terms that we have going on there. How many total terms? 5, Cole? Is there 5 terms? Why not? The dots signify that it's not just those 5 numbers, right? Okay. So we might have to use our rule formula that we had from yesterday, right? Because that's got an n in it. Right? And we have that last term. That last term is 48. We have that first term. That first term is 3. Do we know what our common difference is? Adding 5. So that's going to be a positive 5 in there. Yeah. Oh, now we can do some math. We like maths. So then this is going to be 48 equals 3 plus 5n minus 5. 50 equals 5n. So 10 is n. Here's 10 terms in that series? So now we can find the sum. So the sum of the first 10 terms of this series is equal to the total number of terms, 10, divided by 2, plus, or times the quantity, the first term plus the last term. Ten divided by 2 is 5. 3 plus 48 is 51. So the sum of the first 10 terms is 255. Agree? Okay. Now, we're going to take a moment to refresh our memories from Monday about summation notation and the sigma. Remember that in the sigma, we need a variable, a start, an end, and a rule. Okay? So, variable we can handle. Anybody got a preference for the variable?
10.
10? Okay. Number you want to start with? An infinite number to choose from. 1. Okay, start with 1. What are we going to end with? If we started with 1, we're going to end with, nope. We're going to end with 6 because there's 6 terms. Okay? Then we need a rule, right? Well, first term is 16, right? I'm going to leave it at n because in my common difference looks like we're going down by 8. So could that be our rule? Would that work? Yeah, that would work. Or what would that be? Plus 24? Yeah. Right? Find me the sigma notation for that second one up there in yonder corner. Agree. Yeah, but okay. The reason I say that is because summation notation means just that. It means you have to find the sum. That's what summation notation or sigma notation is all about, finding the sum. Well, now with an arithmetic sum formula, it's actually pretty easy. Because to find the first term, what you do is you plug your start into the rule. So I'm going to plug 1 into 3n plus 2. 3 times 1 is 3, plus 2 makes 5. So my first term is 5. My last term, I'm going to plug the end into the rule. So that's going to be 3 times 65 plus 2. 3 times 65 is 195, plus 2 is 197. And then my total number of terms is going to be the end minus the start plus 1. So that's going to be 65 minus 1 plus 1, or just 65. Now I've got enough for the sum of the first 65 terms is going to be 65 divided by 2 times the quantity 5 plus 197. So that's 65 divided by 2 times 202. So that's 65 times 101. So that gives me the sum of the first 65 terms is 6,565. Arithmetic sums are nice in sigma notation. Questions, comments, concerns, clarifications? Try it. First term is going to be 12 times 6 minus 8. That's 72 minus 8. That's 64. The last term is going to be 12 times 80 minus 8. That's going to be 960 minus 8 is 952. Total number of terms is going to be 80 minus 6 plus 1, which gets me 75 total terms. So the sum of the 75 terms of this series is going to be 75 divided by 2 times the quantity 64 plus 952. Oh, what's that? 1012? No, 1016. the sum of the first 75 terms is 38,100. Yes? Plus, now we don't have to sit here and go through and add up 75 different numbers together. Formulas makes it look nice. Love it. This is the last one. Go for it. Oh, what's that? 800, 1120, so 1108. $10.96. $153,988. Yes? Good. Good times. Okay, so your homework this evening. What? What does that mean? Starts with the homework for today and it ends with you having fun? Yeah, buddy.